kidding. All right. So before we start on the properties of logarithms here, let's talk about what it means to be a logarithm, right? So if you're ever asked this question, we kind of touched on it before. What is a logarithm? It is a exponent, right? A logarithm is an exponent. And yes, if you have questions on homework, we'll tackle it after I teach, right? So we can hit everybody. Okay, so a logarithm is an exponent. Today we're going to talk about what we can do if we have logarithms of combinations of elements, right? So we're going to talk about three properties, the first of which is the product property, right? So when I say product, what operation is that? Adding, subtracting, multiplying, dividing, Bernie?
Multiplying.
Multiplying, precisely, right? Now let's just think about exponents for a minute. If I have x squared times x cubed, if we're multiplying, right? What would that equal to? X to the what?
Sixth. X to the fifth, sorry.
Fifth. X to the fifth, right? Because we add the exponents. So now look, if I say log of x squared times x cubed, now if I say log of x squared times x cubed, when I say log, that's exponent. I'm telling you, right? I'm asking you, what is the exponent of x squared times x cubed? Well, it's the exponent of this one plus the exponent of that one, right? So when I am multiplying, there is a little bit of addition involved, right? Well, it's the exponent of this one plus the exponent of that one. And wouldn't you know it? That's actually the property. So the product property is this. If you have log of something times something, each of the elements inside get their own logs, and product translates to adding. Okay? All right, so that was the background, but let's just use the property. Okay, here I have log 3 times 5. You're going to count how many elements are inside the log. I have a 3, I have a 5. That's 2. So that means when I'm done, I'm going to end up with 2 logs, right? Each of these elements get their own log. So log of 3 plus log of 5. And that's it. That's all you do. Okay? All right. Next one. I have log base 2, 5, 7. 2 elements. Each get their own log. Log base 2 of 5 plus log base 2 of 7. So look at the bases. Whatever the base is here, you just copy it over. You literally clone the log, so it has to be identical. No base here either. Okay? Questions? All right, let's do one more. Here I have an ln, 4x. 4x, 2 elements. So I get ln of 4 plus ln of x. Okay, any questions? Okay, here I have 3, a 5, an a b. So I get log base 2, 5, plus log base 2 of a, plus log base 2 of b. Okay? What are some pitfalls? You might forget to carry over the base, or you might forget a very common mistake is a student will say log base 2 of 5 plus log base 2 of AB. They lump the AB together. That's a very, very common mistake. But remember, you have to always count first, then make sure you have that many logs. Okay. Can somebody volunteer for this one? Raise your hand. Kaden?
This would be log base 4, 3 plus log base 4x plus log base 4y.
Fabulous. Okay, good, thank you. Next I have ln of 5 root x. So this will be ln of 5 plus ln of root x. Okay? Now this one, I'm going to put a little star next to it because it's not quite done. We're going to come back to it later. Okay, next. What if you have to express a logarithm in terms of logs of two constants. So look at this one. It says to express log 12 in terms of log 3 and log 4. So basically you have to break down the 12 into like 3s and 4s. So here's the process. Break down the constant. So you say, okay, how can I write 12 in terms of 3 and 4, right? One way to do it is I say 12 is 3 times 4. Oh, that's it. Okay, so 3 times 4. So log 12 then is log 3 times 4. And then let's use the properties of logarithms to expand this. Well, this will be log of 3 plus log of 4. All right. Okay, let's do another one. I have log of 6, right? And I want to rewrite it as log of 2 and log of 3. So log of what's 6? 2 times 3. So it has to be, you can only use 2s and 3s. You can use both 2 and 3 or just one of them, it doesn't matter, but you can't use like a 4 or a 2 or a 5 or whatever. So now that's log of 2 plus log of 3. Okay, before we go to the next one, I'm going to modify it a little bit, make it a little bit more interesting. I'm going to make it log 45, not 15. And we have to write it in terms of 5 and 3. So somehow you need to break it down, right? Okay, like this might be a little bit more complicated. So let's see, what's 45 made of? Well, it's 9 times 5. But I can't use a 9. But I can use it as 3 and 3, right? So this could be log of 3 times 3 times 5. Which means it's log 3 plus log 3 plus log 5. Okay? And what's log 3 plus another log 3? That's 2 log 3 plus log 5. Okay? All right. Let's do one more. Hey, Maddie, welcome back. Okay, let's do one more property. Next, I have the quotient property, which means dividing, right? So if I'm dividing powers like this, what do I do to the exponents?
Subtract.
Subtract them. So the quotient property, if I have log of m over n, is log m minus log n. Okay. So here then, if I have ln of 3 over x, then that is ln of 3. And because x is being divided, minus ln of x. Okay? Same with this one. Log base 3 root x minus log base 3 y. Okay. Questions? But now if you have more than one thing in the numerator or the denominator, right? There is a very quick way of figuring out what to do. Each element in the numerator is added, and each element in the denominator is subtracted. So let's do this first one. Look, how many terms do I have? I have a 2, I have an A, I have a B. That's 3. So I start, okay, log base 3 of 2. That's in the numerator, right? So it's positive. Next, A. A is in the numerator, so it gets a plus sign. I'm sorry, A. Next, it's B. That's in the denominator, it gets a minus sign. Okay? All right. Does somebody want to tell me the next one? Volunteer for the next one? Done, go ahead.
Log base 2 5 plus log base 2 x minus log base 2 3 minus log base 2 y.
Fabulous. Okay? And it's just convention. It's common that the ones with numbers, right, we write them in the front. So we can like swap and say log 5 minus log base 2 of 3 plus the log x minus the log y. But it's completely voluntary, like it's optional. Okay. E. Bernie, you want to do E?
Sure.
Okay.
ln2
Mm-hmm.
plus lnr minus lnt.
Fabulous. Awesome. Okay. Last but not least, the third property is the power property. And this has to do with exponents. If you have an exponent, right, log m to the power of p, the exponent comes down and becomes a coefficient of the log. That's it. Pretty straightforward. So if you have this one, a, it's log x squared. The 2 just comes down and you get 2 log x. Okay. Okay. Look at the next one. I have 2 elements, x squared, y squared. So I'm going to get 2 logs. Log base 3 x squared plus log base 3 y squared. But now each of the 2's come down and become coefficients. So I get 2 log 3 of x plus 2 log 3 of y. Okay? Any questions? Okay, this one. ln of root x. So look at this one. Whenever you have a root, you first write the root as x to the 1/2 every time. And then the 1/2 comes down. So it's half ln of x. Okay, next one. Here I already have a 3 in front, right? So, and then I have 2 elements inside. So I'm going to leave the 3 out here and then do the rest in parentheses. Okay? So this will be log base 2 a squared plus log base 2 of b. This is 3 times. The 2 will move down, so we get 2 log 2 of a plus 1 log 2 of b. Okay? And now, if you want to distribute the 3, you can, but it's optional. So it could, you could rewrite it as, 6 log 2 of a plus 3 log 2 of b, but either this or this are okay. Questions? Okay, this next one is really exciting. Look at this one. I have a root. So first I need to rewrite the root as a 1/2 as an exponent. Okay, then 1/2 comes down. But now, this is 1/2 times. I can actually simplify this, right? Like we were doing in the last lesson. What's log base 2 of 32? This is asking me what is the exponent of 2, right? Cooper, any ideas?
So that's a good question.
So we're looking for the exponent of 2 that would give you 32. So 2 to the power of what is 32?
I'm thinking 4 because I feel like 5's too much.
One more, 5.
Oh, it's 5. Well, then 5.
4 is 16. So this is a 5. So finally, all this is 5 over 2. Okay. Okay, next. This one. This is 3 times log 7, 49 to the power of 1/6. Okay, the 1/6 comes down all the way in front of the 3. Okay. So now, 1/6 times 3, that's 1/2, times, how much is this? Log 7 of 49. 2, right? 7 to the power of 2 is 49. So all that gets reduced to 1. Oh my God, who knew? That complicated thing is just a 1. Okay, so next, I want you guys to do this one on your own. You're going to get a numerical answer, just a number. And when you get your answer, please put it in the chat for me. So it'll be 12 ln of e is 1 minus 4 ln of e is 1. So that's 12 minus 4, 8. Fantastic. So awesome. Okay. Before I do the summary, remember how I had put a star next to a couple of them way back when? sorry, here was the first one, right? Remember this one? This is on page 19. So we had gotten ln of 5 plus ln of root x. Well, we didn't know it at the time, but the root x can simplify further. So this is really ln of 5 plus ln of x to the half. And when the half comes down, it's ln of 5 plus 1/2 ln of x. So if you want full credit, this is the one. If you just want partial credit, any of the above steps will work as well. Okay, Sam?
Do you mind just going back to the last problem I wasn't able to write down?
Yeah, I'm
for?
actually going to go back right now.
Oh, thank you.
This one more as well. There was another one here, right? Look at this one on page 20. Okay, quotient property. This one too, right? We rewrite it as x to the 1/2 minus log 3y. Half comes down, half log 3x minus log 3y. So again, partial credit is the top two, but if you want full credit, bottom one. Okay, it's a choice. Okay, last but not least, let's summarize. How do we expand logarithms? First, you want to expand it so that you have as many logarithms as there are elements. Okay. We rewrite exponents as fractions. I'm sorry, as coefficients, sorry. And if something is in the numerator, it's added. And if something's in the denominator, it's subtracted. Okay. And that's where we're going to stop today, and you're going to do the homework, which was a handout, right? But